Hello everyone. Now I will solve traffic lights of CSES problem set. Okay. Now let's jump to the problem statement. There is a street of length x whose positions are numbered from 0 to x. Cool. Initially there are no traffic lights, but n sets of traffic lights are added to the street one after another. Okay. Your task is to calculate the length of longest passage without traffic lights after each addition. Like we have to continuously find the longest passage without traffic light. Okay, so let's see the inputs. We have given x and n, so length of the street and the number of traffic lights. Okay, and we have integer of array length n. We have an array of length n, and what we have given that the position where like traffic light will be set. Okay, so we have to print the longest passage without traffic light after each addition. So let's take this test case and understand the problem very well. Okay, so we have given like the street of length 8, 0 to 8, and the number of traffic lights should be 3, and their positions are 3, 6 and 8. 3, 6 and 2. Okay, so what would be the initial longest passage without traffic light? Like suppose there is no traffic at all. So what would the maximum what is the longest passage without traffic light? It would be is final minus initial. That is the length. So x minus 0 would be x. So can we assume like suppose if there is traffic light here suppose. Okay. So how will we find the length of here? So we can assume here like there all at the end of we can assume there is traffic light at the end and at the beginning of the street. Okay, to find the length. Okay, so let's calculate for this. So initially we have street light is set at 3. So this is 0, 1, 2, 3. So here street light is set. Okay. So what is the longest passage without traffic light? So here we have just 3, here we have 5. Okay, so answer would be 5. Cool. So now traffic light is set at 6. So this was 3, then 4, 5, 6. Here we have traffic light. So what would be the maximum passage? This 3. Okay, we have 2, 3, so answer would be 3 only. Okay, now traffic light is set at 2. So we have this 0, 1, 2. Okay, what would be the maximum? What will be the longest passage? Still 3, this one. Okay, so still answer would be 3. Okay, so now let's see what we can do here. Okay, so let me come here. Okay, so suppose these are the segment. Like this, like this is the state full, and like these are segment length I have written here at the upper side. And okay, so suppose if a new street light is added here, okay, what will you do? What will be the answer if new street light is added here? Still the answer would be 6 because still this is the longest one. Okay, suppose street light is added here. Still the answer would be 6. If it is added here, still the answer would be 6. If it is added here, suppose in between the segment of length 6. So what will be the answer? Here first we have to divide and see what is the length of resultant segment. So here we have length of 4, Here we have length of 2, and we also have 5 here, so the answer would be 5. Okay, so we have to we have to store the length of the segment. Okay, we need to store the length of the segment. Okay, so that we can like easily assess what is the maximum length. Okay, so let me get this. And what are the things we have to do? So yeah, like what is the initial thought process? Suppose if I am at any particular index, suppose I am installing the traffic light, ith traffic light. Okay, and here we have some segments already that is created. So okay, so what is if I am inserting ith light? So what will happen? What are the things that has already happened? Some segments are already created. Segments are already created. Is it? Yeah, created. Okay. So now what we can do now? If we have segments, so we have to insert in position and divide that particular segment. Okay. Okay. Like suppose if this is the position where we have to insert the light. So first we have to delete this segment length 5 and insert two new resultant segments. Okay. So if I the light is, suppose here we have inserted a new light. Okay. So new, first we have to delete this 5. Cool. And we have to insert 2 and 3. Okay. So do you, first of all, let me think what data structure to use. We need every time maximum length. Okay. So do you think priority queue would be better? Let's see. If like it can be good idea. So what are the things we can have to do? Suppose we need maximum every time. So priority queue comes in our mind. Okay. So what we have in priority queue, we only get to see the maximum one. Okay, we don't get other elements of the priority queue. We get only the top one. So suppose, but I want to change here also now. Suppose, so what will happen? We can't use here priority queue. Why? Because I have to change according to the like array which is given. Suppose if I have to install here, I have to install the lights here. So I have to change this. I have to first remove this and then insert also. Okay. So I can't do this with the priority queue. Okay. So what we can do? We need some sorted data structure. So we can think of set also. Okay. So can we use set? We have to use multiset because there can be two segments of equal length. Okay, so can we use multiset? Multiset. Okay, so that's my right now thought process. Okay, So if I am I am at the ith index, I if I am setting the ith light, so how can I find the length, the position of this one and this one? That's why I can find the segment. Is it not? If I have to insert light here. So to find the to find this segment length and this segment length, we need the position of this where these street lights were already installed. Yeah, is it not? So how can we do this? So we can do this we can find the upper bound of this. How can we find the upper bound of this? We can find upper bound, so it will give this one, the position of this, and we can find upper bound minus I we can just decrease the iterator. So upper bound will be this. Then if we decrease, then it will directly come to here. Okay, so we will get this and this. Okay, so let's code it if we will understand better. Okay, so let me think, see what are the things we need. First we had X and N. Okay, cool. C, X and N. Okay, so we have this street length and we have number of street lights. And to store the segment, we have on multiset, sorry, multiset, multiset into. It would be better to write segment. And we also need to find the position upper bound of installed traffic lights. So we need set also here. Set into lights. So initially, what is the where are the lights at the starting and as well as at the end? Okay, so li lights dot insert 0 and x. Okay, and what would be the segment length? Segment length would be seg dot insert. It would be x initially. So now we can take we can insert the traffic lights. Okay, first we have to insert the traffic lights. Okay, let me bring this. So it would be better if I need to explain. Okay, so initially we don't suppose we have at the starting and the end. Okay, now we insert a traffic light. Cool. We insert a traffic light. So what we want to find? We want to find the upper bound. So what would be upper bound of lights? Is it now? Lights dot upper bound, and what it would be T. Okay, so he it would be auto IT1. Cool. And and this, and we have auto IT2 equals IT1 minus. So suppose if I am inserting here, so upper bound of this would be this traffic light and this traffic light. Okay, so we got the positions. Cool. Now what we can do? We have to first remove that segment. First we have to remove that segment where that this light was present. So how can we? So we can find the length of this. Cool. So what would be int length equals IT1 minus IT2. Okay, so we have found the length. So we need to find a segment of length IT1 minus IT2. Okay, so we have to erase that. So segment dot erase length. Can we do this? There is a problem here. Let me tell you. Suppose we have two segments of length 5. Okay, so it will I think erase both of them. So like uh, it's better to do find the iterator of particular length, so it will find the one iterator and it will delete only one element. Let me tell you how. Seg dot find length, so it will find the length and it will return iterator. Now this iterator will be erased. Okay, so it will return the iterator of just one element of 1 5. Okay, so that's why it's better to use this. Okay, so we have now erased the iterators, that particular segment. Okay, now we have to insert the new resultant segments. Okay, seg dot insert. What we can do? What we have to insert? Star IT1 uh, minus T. Okay, and what we can insert T minus star IT2. Cool. We have inserted the two resultant segments. So now what these are the things we can print. What we can print? We can print the maximum, currently the maximum length of segment. So seg dot r begin. Okay, it's good. So it will start from a reverse. So if it is at reverse, so it it will have maximum element. Okay, star. Let me write here star. So let me check this. There is some compilation error. 48 line. Int length equals IT1 minus IT2. Okay. So can't we do apply the operation? Uh, so okay. So what we can do here? We can do this here also. This. I think that would be fine now. Okay. Okay. So I have done some blenders. Okay. So what I have done, we have iterator which will have this. So int left equals star it1 star it1 int sorry right gh and int left would be star it2. Cool. And what we can do here, int length would be left minus right, right minus left. So we have find. Okay, so I can do right ingst and here I can do left. Cool. Now let me rerun this. So there is some error. Okay, so let me. Okay, so the main problem is here. Okay, so what's the problem here is that here I have to do pre-decrement. Why? If I am doing post-decrement, so what does that mean? IT2 will be equals to IT1 only. Then afterwards IT1 will decrease itself. Okay, listen. IT2 will be if I have done if like if IT2 equals IT1 minus minus. What does that mean? It means IT2 equals IT1 and then IT equals IT minus 1. So that's the you can find the code like this means this code. Okay, so it will be better for you. And what does that this mean? If IT2 equals minus minus IT1, this means IT first it will all decrease by itself. IT1 equals IT1 minus 1. Okay. Then IT2 will be equals to IT1. Cool. So that's the main difference. So and also I think I forgot to insert the like lights. So where I have to insert the light. Uh, First we have to find this. Okay, upper bound, and then we can insert anywhere here. Let me lights dot insert t. Cool. So now let me check and run. So it's a quite an interesting problem. Oh, so let me submit it. Yeah, so we have solved it. So what are the things we have learned here? We have learned like so some of the like basic things we also like the importance of post decrement and pre decrement. We have learned why we have used upper bound here again. We have learned okay why we have used multi-set, why we didn't go with priority queue. We have learned that. Okay, why this thing why did we do this thing? Because we don't want to erase all the elements of length 5, let's say 5. So that's why we first find the iterator of that particular length. So it will return just one iterator, then we can delete that. Okay, so it was quite an interesting, and also this one, if you don't know that, because we usually don't use that. So R begin that means it starts from reverse. Okay, cool. That's it from my side. Bye.